Hello everybody, this is 𝗤𝗂𝗃𝗃 and today I am going to talk about quantum computers or quantum computing. So there is a system which is launched by IBM, which is an IBM Quantum Computing System 2. So what it is actually. So before we get into that, we like to understand what exactly is the quantum computing means, right? So in today's conventional or classical computer environment, computer science, we used to represent internal representation as zeros and ones, right, bits. But in quantum computing, you will have a third stage. So 0 and 1, it can be either 0 or 1. It's a maybe or both, right? Something, it's a third state. So which is called as in qubits. So it works on the basis of qubits, and it's a mechanism involved is quantum mechanics or quantum physics, with which we are going to run the computing methodology. So when you do so, you have an internal architecture, it changes, right, and it works within third stage. Let's say, for example, simple example is, if I toss the coin, it's going to be either one of two choices, either 0 or 1, head or tail. So that's what so far we have seen. Now it is going to be the third stage. So when you toss the coin, it is going to go up and down. So there is a third stage which is referenced with the help of a superposition. So in what stage, what is the possibility of this head or tail, and right, that superposition, entanglement, measurement at when the head or tail is going to happen. So these will be measured with the quantum physics concepts, and so we can able to derive multiple methodology for solving a problem. So traditionally we have a single approach to solve the problem. Here you have easily get the multiple options to solve the problem. So the quantum computers are designed to solve the complex problem, right? So which means in today's successful version, whatever we have, it has been there research for more than almost a decade. So the successful version which is released is actually quantum computer system 2, which works on which is normally called as an first modular utility scale quantum, right? So which works within 133 qubits of Heron processor. So this is now available in the form of a modular nowadays, so which is now could able to perform 5000 instructions per single quantum circuit. So which means if this same modular thing, if it is coupled, quantum coupling technology, with which these you can see the pictures of how the processor system looks like. It is actually 50 feet long, and it will be maintained in a very deep cold temperature, and of course it is actually it's operate with its own superpowers, and it is currently a modular, and if it is coupled together, right, and then it can able to perform in the next 5 years, it can able to perform 100 million instructions per single quantum circuits, and if it scales up, it's going to be 1 billion instruction can process in a single quantum circuit. So that's how the super fast is going to happen, which means this will evolve the most fast computing. So nowadays whatever we feel as in secured RSA algorithms can be cracked easily with the help of such a super fast computing, and so it's currently whatever we feel as secure need to be, it can be a question mark later. So that's where there is a concept called quantum safe computing is also evolved, which will assess and say how it is safe, right? So that's another category we will be discussing later. And so this is actually a quantum computers all about. So which means your AI, ML, easily you can train the huge amount of data, and you can able to derive it very faster, and you can able to do the drug detection. You don't need to wait for a long time because it's going to process high, so you can sooner you can release much various new innovations. So that's where we are into, and it's a quantum computing era. It's already started, and there is with 133 Heron processing unit, we have an SDK, Q-SCIT SDK, which is able to program your quantum computing things. Of course, I have just explored, and Q-SCID SDK, and you have a runtime environment Probably plotting some visualization is similar to your Python, but internally when you're making use of it involves your quantum physics algorithms and formulas, and so that's about your quantum computing. Keep follow me for the more technical update. Thank you.